So now let's look at a brief history of Six Sigma. So Six Sigma's history isn't as long and as complex as Lean's was, and actually Six Sigma is more of a modern phenomenon. But we can trace it back down to around 1900 when William Seeley Gossett of the Guinness Brewery hired statisticians and chemists to improve the quality and consistency of the ingredients and the beer. And this was the first time we actually saw people like statisticians, chemists, scientists being brought in to look at the quality and the ingredients around this kind of thing. Walter Schulhart, who is actually known as the father of modern quality, he introduced the concepts of SPC, which brought together disciplines of statistics, engineering, economics, and it was him who actually introduced control charts for the first time as a tool to identify if a change in a process was the cause of a chance variation or actually had a root cause. It was Motorola in the 1980s that wanted to move away from measuring defects per thousands of opportunities to defects per million. So if we think about, we talked about Six Sigma, we're looking at that 99.99966%. Motorola is the one that coined that. They wanted to look at those defects per millions, not per thousands. And this was to try and add more granularity to the analysis. And this is where the term Six Sigma was actually born. So the idea of Six Sigma was born in the 1900s, but the actual term was coined in 1980s thanks to Motorola. Six Sigma was instilled by Motorola over the next 10 to 15 years. And in that time, they were able to save over $16 billion cumulatively over that period of time. And that just shows the sheer power and impact that Six Sigma can have within an organization. So as part of understanding Six Sigma further, it's a really good idea to think about good quality versus Six Sigma quality. And when we talk about good quality, we're talking about quality in terms of what most organizations would strive to achieve. So the aim of Six Sigma is to try and get your processes, operations, and performance to Six Sigma level. Now, this is nearly impossible to actually do. It's a very, very hard task to achieve this. Some industries do achieve this, but very few. So the aim really is to try and get as close to Six Sigma level as possible. Now, this in effect means that for every 1 million transactions you make, only 3.4 of them or less result in a defect. So only 3.4 of them or less are wrong or errors. This puts us at 99.99966% accuracy. The classic view of quality expects good quality performance to be at 99% accuracy, which equates to 3.8 sigma. So even though the difference here is 0.99966%, and this may seem small, the impact is actually quite significant. So think about that. That's less than a percentage difference, but the sigma difference is 2.2. That's a big sigma difference. That's nearly 40% difference. So let's look at some examples of the difference between the two. So if we look at the classic view of quality, so 99% accuracy, this is the same as 20,000 lost articles of mail per hour. If we look at it from a Six Sigma view of quality, this is 7 lost articles of mail per hour. So the difference is less than 1%, but the impact is significant. 5,000 incorrect surgical operations per week, 1.7 incorrect surgical operations per week. 200,000 wrong drug prescriptions each year, 68 wrong drug prescriptions each year. Right, so if you can see by these examples, the difference is substantial. And this is why some healthcare providers, for example, are now starting to implement Six Sigma methodologies, because the difference between 5,000 wrong procedures or 200,000 wrong prescriptions and 1.7 or 68 respectively is the difference between life and death, right? So that's why approaching quality from a Six Sigma perspective, even if you never get to 99.99966%, you're still going to get closer than 99%. So this is why people like to pursue Six Sigma quality over good quality.